Hello, I'm Mr. Franklin, and today we're going to take a look at motors and generators in our attempt to answer our essential question, our exploratory question of how is electricity generated. So to do that, we're going to do a quick review of magnetic induction. So here we have a magnet, and we have a coil of wire, we have a light bulb, and a voltmeter. And from what we learned with our magnetic induction, as we move a magnet towards a coil of wire, you're going to get electricity created in the wire, and it's going to light up the light bulb. Now, the secret to this is the magnet has to be moving. As soon as the magnet stops, the current stops flowing, and the light bulb goes out. So let's take a look at this with another animation. And so here we have our magnet. We have a coil of wire. And as it approaches the coil of wire, a magnetic field is going to be created to oppose the change created by the real magnet. To do that, what happens is as the magnet comes down, it causes the electrons in the wire to move. And what's actually depicted is the current, not necessarily electron motion, okay? But as the current moves, we learned that a moving electric current produces a magnetic field. So you have this magnetic field that's opposite in direction. In our induction video, what you saw was a two-dimensional drawing. Just keep in mind this is three-dimensional, which is hard to draw. So basically our magnetic field lines circle the entire loop of wire. As we take a look at an application of this, there's two ways to think about it, and it's really the same idea, just applied in a different order. Motors are devices that convert electrical energy to mechanical work. They're going to use electricity to cause something to rotate or move a load. So this is how an electric fan works. But basically they take electricity as an input and it creates mechanical work as an output. We're going to need a constant magnetic field. We're also going to need a current carrying conductor. So a motor has two magnetic fields that are going to interact with each other to produce a force. And this force is going to cause mechanical action to happen. A generator is a device that converts mechanical work into electrical energy. So it's really kind of the same process, it's just in reverse order. So some things that we see in real life, we have turbines. Our electrical power that we get that powers our homes is created this way. If you use wind energy, basically we have some kind of mechanical work on the generator and it produces electricity. For a generator to work, we need three things: a constant magnetic field, a conductor that is a wire in the magnetic field, and then there needs to be relative motion between the conductor and magnetic field. So note, the conductor can be moving or the magnet can be moving or both, but basically it has to create that thing we've already seen where there has to be a changing magnetic field. In advanced physics we call that magnetic flux. So a generator creates electricity because work is done on either the magnet or the conductor. And this work that's done on it creates electricity in the wire, which is then used to charge a battery, like an alternator in your car, or power homes, like your hydroelectric power. So let's take a look at an example of this. So I've got a magnet here. The magnetic field is constant and everywhere. You can't see it, but it's still there. And now we have our current carrying loop. Let's take a look at this as if it were a generator. So you see how this magnetic field is going down. You're going to have a magnetic field generated in the opposite direction. As I rotate the handle, current moves through the wire and we get electricity. This is the alternator on my car. You can see here's the belt that's connected to the engine. As the belt turns, it causes a rotation inside the alternator. Basically we have a current carrying wire rotating inside a magnetic field, which generates electricity, which goes to keep your battery charged. That's how you could look at it as a generator. Now if it's a motor, what you have is you already have the current going through here. It might be easier to actually look at my drawing here that I've drawn. So we've got our current carrying wire that's actually got current going through the wire. What's going to happen is, as it rotates, you get that pseudo-magnet, that ghost magnet, if you will, but it's a magnet created by the current going through the wire. And we talked about how magnets attract each other. Opposites attract, so the north and south end are going to attract each other, and you're going to get this kind of rotation. This kind of action will only get it through a half turn, because once the north and south align, opposites attract, then it's just going to stick and stay there. So there will actually be some brushes where the wire will actually temporarily disconnect, and so you will have no current running through the wire, but momentum will carry the bar through its rotation until it connects again. But when it connects again, the current's reset to the correct direction to keep it spinning in a single direction. So this is basically how electricity is utilized to power an electric motor or to create electricity. So one of the key things with the motor to remember, the easiest way to remember it, is we have electrical energy being converted into mechanical work, and then we have the generator, which is mechanical work is creating electrical energy. So that's the basics of motors and generators. Thank you for watching. I hope you have a great day, and we'll see you next time.